Alrighty, today focuses around a particular kind of question that comes up quite a bit, and it kind of goes like this. You see these 5 letters here? The question is, how many ways, let's write this out carefully, how many ways can we choose 2 of these? Let's just say 2 letters from 5 different letters to start with. How many ways can we choose 2 letters from those 5 letters to form what I will call a group? And by group, I mean order doesn't matter. That's what I mean. Order does not matter. So let me come down here where it says determining the value of 5C2. All I want to do here is I want to count how many ways can I form 2. Well, I could take the A first, right? So that counts. And then I have to choose another letter. Now you only have one A, so you can't choose another A. So picture it like letter magnets. I've got an A magnet, a B magnet. I've only got the 5 magnets here. So I choose the A and then I choose the B, right? That's one group, one down. I could also choose the A and then choose the C. I could also choose the A and then choose the D. I could also choose the A and then choose the E. Now, don't worry, there's not too many groups here. For example, BA, that does not count. What? No, that does not count. Why doesn't that count? I'm going to say does not count because order doesn't matter. Okay, AB and BA are the same group. When we say order doesn't matter, that's what we mean. We mean A, B, and BA, they just count as one. They're one group. You don't count it as 2 groups, you count it as one group. By the way, you got to get used to this a little bit. I'll say i.e. they are the same combination. So that's what combination really means. It means well, it means a group where you don't care about the order. So AB is a combination of 2 letters. AC is a different combination of 2 letters. Now, where are you getting your letters? You're getting your letters from that group of 5 up there, right? So that's where the 5 comes in. So anyway, let's finish the list here. So we could choose a B first, but not the A. And again, we can't choose another B. There's only one B. So BC counts. Here's BD. That's another one. BE. That's another one. Now, I'm not going to say CB either because that would count as BC. So what have I got? If I start with a C, I could then grab a D or an E. And if I start with a D, I could grab an E. And that's it. If you count those up, there's 10. 10 groups. 10 combinations. Okay, combinations is the official word. You'll hear me say groups a lot. 10 groups, 10 combinations are possible. And so here's a notation that I should explain right about now. So the 5 choose 2. That's how I say that. You say 5 choose 2. So it's got 3 parts to it, right? So let's see. Let's go like this. The 5 is how many are we choosing from? How many are we choosing from? It's the size of the pool, so to speak. We're choosing from 5 letters. The 2 is, how many are we choosing? We're choosing 2. How many are we choosing here? And the C is saying to form a combination, not a word. Order doesn't matter. To form a combination, order no matters. Order no matter. Okay, and it turns out we just figured out down here that 5 choose 2. Well, we listed all the combinations of 2 when we found 10 of them. Doop, 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 doop. So 5 choose 2 is equal to 10. That's what a combination means. It's I got these 5 things and I'm going to choose 2 of them, and I don't care what order I choose them in. I'm just caring what. It's kind of like if you're choosing a committee where the committee of 2 is not going to have a distinction between, oh, that one's the main member and that one's the auxiliary. It's just 2 people on a committee. 5 choose 2, whatever. You can choose 2 of anything. So right now you're probably getting a little nervous. You're saying, oh man, am I going to have to be listing out all these things all the time? And the answer is no. This is the part where you get out your calculator. Let's kind of squeeze this in here in purple. You know what I'll do? I can do better than that. I can squeeze this in. Get it? Hey, squeeze, squeeze, squeeze. Okay, now move over here. So 5 choose 2 equals 10. Okay, now I'll get out the calculator here. Let's kind of block off some space. So if you grab out your calculator, what you want to look for is a button like this. It might go, let's see, what's my button look like exactly? My button, yeah, my button has subscript notation and all that. So you want to look for a button that looks like this. Now, on my calculator, I have to hit a shift key. So you might have to hit a shift key to find it. Hopefully you don't have one of those weird calculators where you have to go through the math menu finding it and stuff like that. Get yourself a Casio FX 300 or 115 will work. ES. Those are the nice ones. And then you'll see the NCR button is a little bit below the AC button. So if you grab yourself an NCR button, calculate with an NCR button, you would do this way. You would type in the 5 first. Then you would hit the NCR button like that. Then you would hit the 2, and then you would hit the equals. And if you have a calculator like that, it'll spit out a 10. So you can use the NCR button to figure out anything, choose anything else pretty much. You know, anything that's legal anyway. 5 choose 2, 5 choose 3, 5 choose 4, however many you want to choose. 10 choose 3, you know, whatever. So that's the good news. It's on a calculator. So now we know what a now we know what a combination is. We know how to calculate it. Cool. Let's get to the examples then. I got 10 examples for you. This will show you the why you're learning this combination stuff. And turns out it can be an amazing shortcut sometimes. So a certain cooler has 8 Cokes and 6 Pepsis. Okay, cool. We're going to grab 4 cans at random. Question is, what's the probability all are Cokes? This is an example we've done before, but we're going to do it in a slightly different way. You want to think like this. What we want to do is come on pen, we want to choose 4 Cokes, not from the cooler really, but from the group of 8. You want the 4 cans to all come from that little group of 8, right? So how many ways can you choose 4 cans out of the 8? And the total possibilities would be, well, you think of it this way, the total ways to choose 4 from the cooler. From the cooler of 14. I'm going to choose 4. How many ways can I choose 4 from the 8 Cokes? How many ways can I choose 4 from the cooler? The ratio of those two possibilities is going to give us our probability. So let's see. 4 choose 8. Now remember, that's not 4 choose 8, 8 choose 4. You've got 8 to choose from, and you're going to choose 4. That goes on top. You got 14 to choose from, and you're going to choose 4. That goes on the bottom. So grab out your calculator button there, and 8 choose 4. I got a 70. And 14 choose 4. I got a 1001. Okay, cool. Now, I was mentioning the Casio not long ago. If you have the Casio, you can just enter that, and it will tell you right away that this reduces to 10 out of 143. I do hope you have a calculator that reduces automatically. Save yourself a lot of grief that way. But anyway, it's 10 over 143. That would be a good answer. We could turn it into a decimal. On the Casio, by the way, you would hit the SD button, which is kind of above the 2 red buttons or green buttons or whatever color your buttons are. Right above the DEL key, you'll see the SD key. Anyway, you hit that key and it'll turn it into a decimal for you, a lickety-split. And I got something like 0.069, what else did I get, 930? That's another 9. 0.069930, so you make a decision how you want to round it as a percent. I think I'll just call that 7.0%. It's a 7% chance that you get all Cokes. Now, you got to admit, that's kind of slick. I'm choosing 4 from the 8 Cokes is what I'm trying to do. What I'm actually doing is choosing 4 from 14, but what I'm trying to do to win is 4 from 8, right? So the total number of ways I can draw 4 from 14 is this way. The number of ways I could draw 4 and have them all be Cokes is that way. I'd have to draw them from the 8 Cokes. And so you just put this over this, boom, 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 push buttons, boom, done. I love that. Here's another good example. What's the probability we're going to get 2 Cokes and 2 Pepsis? Okay, 2 Cokes and 2 Pepsis. Well, what are we trying to do? We want what? 2 Cokes and from the 8 Cokes, right? And 2 Pepsis from the, how many Pepsis are there? From the 6. Over the total ways that you could choose for from the total of 14 cans. Okay, so let's kind of interpret this way. 2 Cokes from 8. Looks like this. There's 8 Cokes. We're going to choose 2. We've seen in the previous lessons that the word and, we're talking a multiplication. Remember the multiplication rule. You're going to do this and that. Well, you're going to multiply the possibilities or the probabilities. Doesn't matter. It's the same. And what else are we doing? We're choosing 2 from 6. 2 from 6. So you have 6. You want to choose 2. That's what goes on top. So you've got this many ways of getting 2 Cokes and this many ways of getting 2 Pepsis. And you multiply those to get the total ways that you could get 2 Cokes and 2 Pepsis. Okay, cool. And the total, you got 14 cans total. So you're going to choose 4, right? That's the same as we had in part A, or example 1, I should say. This comes out to, you push some buttons, you get a 28 times a 15, and this, of course, is the same number, 1001, right? And if you hit your auto reduce button and all this stuff, it's going to be a 60 over 143 is how it reduces. As a decimal, that's about 0.419580. I always like 6 digits for my decimals. So decide how to round that. I'm thinking 41.958. Yeah, let's just call that 42.0%. So it's like a 42% that you'll get 2 of each. So I hope you're starting to dig this. I like this a lot. I want to get 2 Cokes and 2 Pepsis. Boom! I got 2 Cokes, I got 2 Pepsis. Cool. What's this other one? Probability at least 1 is a Coke. At least 1 is a Coke. Okay, well, I'm going to take a leaf. What do I want to do? Take a cue. Yeah, there it is. Take a cue from some stuff we did earlier. Remember the complement rule? The at least 1 rule. So at least 1 Coke means not all Pepsi. And all Pepsi should be an easier thing to calculate. And then all we have to do is go 1 minus that, right? So at least 1 Coke is the complement of, in other words, not all Pepsis. Okay, cool. What's all Pepsis? All Pepsis would be, I don't have to write it out, I don't think. I got 6 Pepsis and I'm going to choose 4, right? We're still choosing 4 cans. Out of 14, choose 4. So 6 choose 4, out of 14 choose 4. That comes out to a 15 over 1001. So we're doing the complement. So 1 minus 15 over 1001 comes out to, what is that, 986 out of 1001. And that's reduced already. There's no reducing there. So as a decimal, that's about 0.985015. So I would round that to like 98.5%. So it's a pretty darn good chance you're going to get at least 1 Coke. I mean, there are a lot of Cokes in there, right? Okay, so hope you're digging this. Deck of cards. This is one of the best examples of combinations. You got these 52 cards. We've seen the deck of cards before. Okay, now let's ask ourselves, example 4, what's the probability we're going to get a flush? Now, there's 4 kinds of flush. You could get a flush in spades or in hearts or in diamonds or in clubs. Let's just think about one kind of flush first. So let's just consider flush in hearts. A flush in hearts. What do you want? You want to choose, you're going to be dealt 5, right? 5 cards are dealt. You want to choose 5 from the hearts. There's only 13 heart cards. Because if you choose 5 heart cards, it's a flush. there's only 13 to choose from. So you want to choose the 5 from the 13 hunts, and the total is, how many ways can you choose 5 from the entire deck? Right, that's the total number of things that could happen. So notice it's 13 heart cards trying to choose 5, 52 cards in the entire deck choosing 5, and if you work this out, that should come out to a 1287. This comes out to a 2,598,960. Whoa. So this is about a 33 and 66640, or just as a percent, something like 0.05%. Not very likely that you're going to be dealt a heart flush. Now, this question wasn't heart flush. This question was any flush, right? So we can go like this. We can say it's the same for whether, whatever your suit is, diamonds, spades, clubs. And these are mutually exclusive, right? You can't have a flush of hearts and a flush of diamonds at the same time. And since they're mutually exclusive, remember that means the probabilities add. So it's basically 0.05% plus 0.05% plus 0.05% plus 0.05%. It's a 0.05% chance of 0.05% chance of a flush in hearts. It's a 0.05% chance of a flush in diamonds, spades, and so the total is about 0.20% chance of any kind of flush. Still not very likely. You're not going to be dealt a flush very often. You might be able to throw away a card and then get a flush, but you're not going to be dealt a flush very often. Okay, let's look at this next one. How about just getting dealt 4 aces? That's a good hand. In fact, it's better than a flush. That's interesting. It's better than a flush, so we expect this to be a lower probability, right? So let's find out. Probability of being dealt 4 aces. What do we want? We want all 4 aces, right? Now, we have to have 5 cards in our hand, so all 4 aces and another card. That's going to be our hand. And again, the total possible hands is going to be 52, choose 5. So how do you get 4 aces? Well, you'd have to choose 4 aces from the 4 that there are, right? There's only one way to do that, by the way. 4 choose 4 is 1. So if you want to choose a group of 4 aces, you have to choose the aces from the group of 4 aces. You have to choose all 4 of them. So 4 choose 4, that comes up to 1, like I said. And another card. Well, there's 48 cards left, and you can choose any of those. You need one more card to make your hand. So 48 choose 1, and that'll be over the 52 choose 5. And the 4 choose 4, like I say, is a 1. 48 choose 1 is 48. And so it ends up being 48 over that big number, 2598960. And if you auto reduce, it comes out to 1 over 54,145. And I'm happy to leave that probability just like that. If you make a percent out of that, it's going to be so tiny, it's going to be like you won't be able to interpret it nicely. It'll be meaningless, basically. But 1 in 54,000, what would this one be? If I wanted to convert this to 1 over something, oh, wait a minute, I guess I'd have to multiply by 4 first. Let's just do this. 0.2% means 0.2 out of 100, right? Because percent means per 100. That's the same as 2 out of 1,000, which is the same as 1 out of 500. So that was a 1 in 500. This is a 1 in 54,000. So yeah, you're very not likely to be dealt 4 aces. 2 more of these. Okay, what is the probability of being dealt exactly 3 kings? Hey, you might be able to do that. You might be able to do that if you feel like pausing. You're going to challenge yourself a little bit. Can you do this? Okay, you've unpaused. Well, what do we want? We want 3 kings. 3 of the kings, I guess. And 2 of whatever else. Of anything else, really. 2 of anything else. So 3 of the kings. Well, there's 4 kings to choose from. How many ways could you grab 3 of them? That's what that means. Now, you're going to choose, it says exactly 3 kings, right? So you can't draw another king because that would be more than 3 kings. Exactly 3 kings means you have to draw from the other 48 cards. And to get a hand of 5, you'll have to draw 2 more. So it's 4, choose 3 kings, 48, choose 2 more cards. Again, this is out of 52, choose 5. The 4, choose 3 comes out to 4. The 48, choose 2 comes out to, whoops, not 4. Comes out to 1128. And that's all over the 2,598,960. Start to remember that number after a while. If you multiply that all out and then have your calculator reduce it for you, it's 94 out of 54,145. So those numbers are the same anyway. But it's 94 out of 54,145. If you want to make a percent out of that, it's about, what is it, 0.17%. Personally, I think I like the idea of divide top and bottom by 94 is to get 1 out of, and what is that? 54,145. 54,145 divided by 94. It's about 576. It's not exactly, but just about a 1 in 576 chance. Oh, a lot easier to get dealt 3 kings than to get dealt, well, to be dealt 4 aces. It's actually a little bit easier to be dealt a flush. That was 1 in 500. This is 1 in 576. A little easier to be dealt a flush, but not too hard to get dealt a kings by comparison. Now this fourth one is interesting. I'm going to have to put a special note here. Interesting. I'm actually going to write that. This is an interesting example. And I thought I would know how to solve this, and then when I started solving it, I went, wait, that can't work. That's not right. And then I thought of another way, and I said, no, that can't be quite right either. And I'm kind of stumped at the moment. And so we're gonna save this for week 8. Why week 8? When we determine, or I should say estimate, when we estimate probabilities experimentally, so to speak, we're going to use random number generators in Excel. In other words, we'll just deal ourselves 5 cards over and 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 over, and then we'll count how many of them have at least a pair in them. And the ratio will give us an idea of the probability anyway. So this will be an Excel project that we do in week 8. So now I got a real good reason to look forward to week 8. I want to know the answer to this question. You deal 5 cards, what's the chance of getting at least a pair? I came up with 2 ways of estimating it, and I didn't really like either way. So we'll get another estimate based on Excel. Now you have to run Excel forever to get a good estimate. But anyway, that's week 8. Stay tuned until week 8. Let's get back to things we can solve. Okay, so 3 more examples to go here. Example 8. Okay, so first of all, Jeffrey has 26 letter magnets, 1 for each letter of the alphabet, A, B, C, D, E, F, G, all the way up. He randomly throws 5 of them at the cat without replacement. He's got 1 A and 1 B and so on. So the cat's not going to get hit with 2 A's. If you can guess which letters he throws, all 5 of them, you win the game. This is kind of like trying to win a lottery, right? Can you guess which 5 are going to come up? Well, let's see if we can do this. What is the probability you guess all 5 letters correctly? Well, he's going to throw, there's a winning group of 5, I guess I might say. So you would have to win, you would have to, well, let's just write it this way. There's 1 winning group of 5. So you'd have to guess that one group. Remember, order doesn't matter. You'd have to guess that one group in order to win. How many groups are there? Well, there's 26 letters to choose from. He's going to choose 5, and that's how many there is to choose from. So you could just say, well, there's one way to win, because there's only one way to get all 5 letters right. And this will be over a 65,780. That's not a bad lottery if you know. Usually it's 1 in 8 billion chance of winning, right? So anyway, so it's a 1 in 65,780. Okay. What's the probability you guess exactly 3 correctly? Exactly 3. This means that you want 3 correct and 2 incorrect. You don't want 4 correct or 5 correct. You want exactly 3 correct. So 3 correct and 2 incorrect. How many ways can you do that? Well, there's 5 that are correct numbers, or letters, I'm sorry. 5 that are correct numbers, and we're going to choose 3 of those. And then we want to choose 2 of the wrong letters. So the 26 letters, take away the 5 that are correct. There's 21 left to choose from, and you're going to choose 2 of those. Right? Right, 21 left. Okay, so let's work this out. So 5 choose 3. I have to hit buttons here. 5 choose 3 comes out to 10. The 21 choose 2 comes out to 210. I should have mentioned this is all over the 26 choose 5, right? So it's 10 times 210 over that 65,780. So if you multiply that all out, 10 times 210 is, well, 210 with an extra 0 on it. Divide by 65,780, and my calculator auto reduces to 105 over 3289. That would be the sort of correct answer. If I make a decimal and then turn it to a percent, it's about 3.2%. That you get exactly 3 correctly. Okay. Maybe I'll express it this way. Since this is 1 over a number, and I like to think of chances that way. So what I'll do is I'll divide the top and bottom by 105 to get, this would be 1 in. So now I got to take 3289, divide by that 105. It's something like a 1 in 31.3. 1 chance in about 31, 32. 1 chance in about 31.3. Okay. Cool. A lot easier. What's the probability you guess? Okay, let's back to this question. At least 3 correctly. Now, like I say, at least a pair. That one. Come on, you. What are you doing? That one. I kind of gave up on, but this one we can do. So this is good. Here's an example where we can do it. The same question, at least 3 correctly. You have to ask yourself, how many ways can we get at least 3 correctly? What we would want is either 3 correct, 2 incorrect, or 4 correct with 1 incorrect, or 5 correct. You can add up all of those possibilities, and that's how many chances you have of guessing at least 3 correctly. Now, to get 3 correct, remember there's 5 letters that he threw. You'd have to choose 3 of those. And 2 incorrect. So out of the 21 remaining letters, you'd have to choose 2 of those. Okay? Or, remember, or means plus, and means times, or means plus in these things. Well, assuming mutually exclusive. So maybe I should note that. Mutually exclusive. In other words, you can't get 3 correct and get 4 correct. You can't get exactly 3 correct and 2 wrong, and at the same time get 4 correct and 1 wrong. It doesn't work. So these are mutually exclusive, so we can just add. So that's it is important to be mutually exclusive before you do that. It's not just the word or, it's or and mutually exclusive. Then you can add. Okay, so anyway, getting 4 correct. Well, there's 5 correct ones to choose from. You got to choose 4 of them. And then there's 21 incorrect to choose from, and you'd have to choose one of those. Or you'd have to choose 5 correct ones from the 5 that are correct. So you add these numbers up. Oh, let's see. Boy, have I got some number crunching to do. Okay, so 5 choose 3 comes out to 10. 21 choose 2 comes out to 210. 5 choose 4 comes out to 5. 21 choose 1 comes out to 21. 5 choose 5 comes out to 1. So we've got, if we add this all up, what have I got? I got a 210 times 10 is 2100. Add 105, add 1. So I've got 2206. 2206 ways to guess 3 correctly out of the 26 choose 5 ways of choosing anything. And so that means 2206 out of the, what was that number again? It was a 65,780. All right, let's reduce, please. Divided by 65,780 reduces to, doesn't reduce by much, 1103 over 32,890. And that would be like 1 out of, remember how I do this is I divide the 32,890 divided by the 1103. I end up with a 29.8ish. So it's like a 1 in 30. If you want a percent, you can do a percent. Where am I? Come on, you. Oh, I hit the factorial button by mistake. Okay, try it again. 1103 divided by 32,890 equals, make a decimal, so it'd be something like a 3.35% or something. 3.35% that you'll get at least 3 correctly. Notice exactly 3 correctly is 3.2. 3 or more is, it's a little bit bigger. Not much, but a little bit bigger, which you would expect. Okay, so kind of feel like I went through those quickly, but it's a good thing you can pause, right? You can also play. Remember, YouTube, you can set the playback speed to like 0.75, which I've done myself on occasion, or set it to 1.5 if this is all really easy or whatever. Anyway, that's pausing, rewinding, setting the playback speed. These are some of your advantages in YouTube here. So before we leave, I just want to mention something. Permutations. We're not really going to use them, but if you go looking up information on combinations, you're going to see this word kind of like with it, right? So this is just an aside. Let's just make a distinction. If you ask your calculator 3 choose 2, you're going to get 3. If you look next to your NCR button, there's one that an NPR button. Use a P instead of a C. And if you ask it, hey, what's 3P do? It comes out to a 6. Okay, what's going on here? This thing, as we saw, this C is called a combination. It counts groups, officially known as combinations. This thing counts, I'm going to call it words, using it in quotes. The official word is permutations, P-E, permutations. So, if you got the letters A, B, and C, how many groups are there? Well, you can group an A with a B, you can group an A with a C, you can group a B with a C, and that's it. That's all you can do. There's no other ways. You don't count BA separately, you don't count CA separately, and that's it. But if order does matter, that's what I mean by words or permutations. A, B, and BA are different. A, C, and CA are different. BC and BA are different, and I think that's all you can really. No, I already did BA. AB, let's see. You could also do AC or CA. You could also do BC or CB. There it is. There's 6. So there's 6 permutations, which I call words, that are possible. There are only 3 combinations, which I call groups, that are possible. So again, the main difference is here, when you're counting permutations, order matters. A different order counts as a different permutation. It adds to your count. Whereas here, with combinations, order does not matter. If you turn them around, it does not add to your count. Order does not matter. So that's it. It's just 2 variations of the same thing, kind of. But like I say, we're always going to be using these in this course. I don't think we're going to use permutations at all. So anyway, there's your big introduction to combinations. Cool. These are going to come in. These are going to be quite important in the next lesson. I hope you can dig these.